Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 26 of JEE Advanced Physics paper 2017. So let us move to question number 26. Students, let us solve the next question, question number 26. What it says, a uniform magnetic field B exists in the region between x is 0 and x is 3r by 2. This is x line, see 0 here, and from here to here it is 3r by 2. This is 3r by 2. So only in this region the B exists, that is called magnetic field. This is the region number 2, and this region we have got magnetic field present, and this side and that side in 1 and 3 there is no magnetic field. And this magnetic field pointing normal into the plane of the paper, so it is going into, so it is cross. A particle with charge plus q, see here, this is a particle charge plus q, and momentum p, so it's moving with a velocity v, is having mass m, so its momentum is p, directed along x-axis, so it is moving along x-axis, so it has to enter like that only, from 1, so it enters the region 2 from 1 at point p1. This is a point p1 which is y equals to minus r. This is y-axis, this is origin, so this point lies below the origin, so it is minus of r. So this distance is r but negative side, so it's minus r. Which of the following options is or are correct? The first way to see the option 1, which is for b greater than this, the particle will re-enter region 1. So the particle will go and re-enter region 1, that means it will turn back. Whether this is possible? Second, b is this, the particle will enter region 3, this region, it will enter region this, it will enter this region 3 through the point p2, so through this point p2, this would be p2 on the x-axis. Okay, so first of all we will find for option number 2. We'll see what is happening with the second option. Then after we get this value of b, then we can go to the other option like option number 1. When the particle re-enters the region 1 through the longest possible path in region 2. When the particle re-enters the region 1 through the longest possible path in region 2, the magnitude of change in linear momentum between P1 and the farthest point from y-axis is this, and so on. So let us solve one by one. First, let us go for the second option, that is option number 2, which says that B should be equal to 8/13 P divided by QR. If B is this value, then only the particle will enter this region, region number 3, through this point. So it has to enter, it will go like that and it will move like that. So to solve this, let us consider, let us draw the diagram. I will draw over here. This is the region 1, this is region 2, and this is region number 3. This I suppose is the x-axis, this is your x-axis and this is your y-axis, and this is the origin, and this point is P1, which coordinate is minus r, so this distance is r, so this distance is r. Now this point is P2, and this distance from here to here, it is 3r divided by 2 is given in the question. and the magnetic field is N2. This is magnetic field B, which is pointing into the plane of the paper. Now the question is that this has to come out like that, so it has to move in a circle, because when we know that when the charge enters in a magnetic field, it moves in a circle. So if it has to come out from here, so it has to follow a circular path. It has to follow a circular path. Its center might be somewhere else. So I say, suppose that this is the center of this circle. If this is the center, then this distance is the radius, and obviously this distance is also the radius. Okay, radius of that I don't know what is the radius. I will consider the radius as r. So r is the radius of the circular path, and c is the center. Then obviously if this is r, then this should be also r, and to any point on this circumference, it should be r. Now we know this distance, which is 3r by 2. We know this distance, which is r, and this distance is small r. So this distance is, we can calculate r minus this r, that is the distance. So what we'll do, we'll first write few things. Let C is the center of the circle which the charge particle, charge q, negotiates. Okay, now I will write in this triangle, I will consider this triangle O P to C. In triangle O P to C, you can see that O P to C, this sum of the square of this plus this is square of this. That is Pythagoras theorem. That is OC square plus OP2 square is CP2 square. Just have a look. OC square plus OP2 square is CP2 square. Okay. Now, what is OC? OC I can write as CP1 minus OP1. CP1 minus OP1, the whole square, plus OP2 square plus is equals to CP2 square. This is the situation so far. Now we will write the value of R is P upon Q into B. R is Q upon QB, because when a body moves in a circular path with the help of a magnetic field, the force is C, then the force is always directed toward the center, because at this point, suppose the velocity is tangent V, this is Q, so QV B is into, so force is like that. So this is magnetic field, so force is always directed toward the center. This is the centripetal force, and we know that centripetal force mv square by r equals to this magnetic field, that is the force due to magnetic field, that is QVB. So from here you can cancel this, and r I can write as mv upon QB. mv is momentum, so QB. This is the formula that we're going to use. Here the charge given is capital Q, so I'll replace this small q by capital Q. This is r, the radius. This is the radius of that circular path, and CP1 is what? Then we will now substitute the values. CP1 is the radius, so I'll write this is r only, minus OP1. OP1 is capital R, the square, okay, plus OP2 square, OP2 square. So OP2 is R, so that is over. Now OP2 is 3R by 2, So this is 3r divided by 2 the whole square equals to Cp2 square, that is r square. This is value. Okay. Now r is p upon qb. That we will arrange it and put it afterwards also. So let us first arrange this and we'll put that, or you can put r is p upon qb, p upon qb minus r the whole square plus 9 by 4 r square equals to p square divided by q square b square. Next is we'll simplify this expression, that is p upon qb the whole square a square plus b square minus 2 p r upon qb plus 9 by 4 r square is p upon qb the whole square. This expression will cancel out because this is on both sides of the equation. This will cancel out. This goes to the right side of the equation. This goes to the right side of the equation. These two will remain here. This is r square. This is 9 by 4. 4 plus 9, 13. So 13 by 4 r square. 13 by 4 r square will be in the left side, and this will go to the right side, that is equals to 2 pr upon qb. This is the expression that will lie to the right side of the equation. 1 r I can cancel out. These two comes down here, becomes 8. So 13 over 8 r is 2p divided by qb. We want this b, so b will be, b goes to that side and this goes to this side. So we are interested in p 13 over 8 qr. So b comes out to be 2p upon q, 8 by 13 r over here. This is b. So we will write this expression as we have seen, that cancelling these two, I will just shift this towards right and these two will add up. When I add up these two, and I will get something like this something like this, r square plus 9 by 4 r square becomes 2 pr over qb. This is the expression that I am going to get. And from here, this is 4 plus 9, 13. 13 r square divided by 4 becomes 2 pr divided by qb. This 2 comes down, so this will become pr over qb. This expression will remain. This 2 is brought down, so this is 13 upon 8 r square. 1 r will cancel, and we are interested in b, so b goes to that side and this factor goes to this side. So b becomes 8 upon 13 p upon qr, p upon qr. This is the expression for b. That means for the particle to enter at this point towards this region number 3, this has to be the radius. If this has to be the radius, then for that the b has to be like this. That we are getting it, that 8 upon 13 p by qr, 8 upon 13 p by qr. That means this option is correct option, that the value of b should be this. If b is this, then only you will have this type of situation and it will enter region number 3 at this point only, at point p2. This part is clear. Now we will see the second option or first option. The first option, the second option is correct, and we'll move to the first option. What is the first option? That will write here. The first option is, this option is okay. The first option is B greater than 3 by 2 P over QR. The particle will enter the region 1. Now just the thing that if there is a magnetic field existing in a particular region and a particle enters normal to the vertical plane, I mean normal to this y-axis, goes straight into the magnetic field, then it will take a turn because of the centripetal force. It will take a turn, and if that radius is less than the radius that we have considered, that the radius we have found is P upon QB, and that particular radius, it was just leaving the second region. If the radius is little less than that, then it will take a turn. It will take a turn, move in a circle, then it will come out from region 1. So it will re-enter region 1 when the radius is less than that. So our radius should be less than that, and we have considered that this distance is 3r by 2, so the radius should be less than that. If so, the solution of this is that r should be less than 3r by 2. If r is less than 3r by 2, then it will take a turn, and then it will come out of this region 1, re-enter this region 1. It should be less than that. R should be less than this. If r is less than this, then r is what? R is P over QB. It should be less than 3r by 2. If it is the case, then what is B here? So we'll write that QB upon P should be greater than 2 by 3r. Okay. If you reverse this, just changing it, it should be 3 by 2. B, we are interested in B, is 3r by 2. It's 3r by 2. So it is 3 by 2. If I reverse it, then it should be greater than 3r by 2. If I reverse it, it should be. So this part is clear that if this is less than this, then this will be less than this, and QB upon P will be greater than this, and from here the B value is greater than 2P by 3RQ. If B is greater than this, then it will re-enter. So the magnitude of B should be greater than this value, and this is 2 by 3 times P upon RQ. But here it is given that is 3 by 2 times. So this is much greater than this. Then it's okay. With this also it will re-enter. So this option is also correct, because this is the condition and this magnetic field satisfies this condition. So this option is also correct. Now, as far as this option number 3 is concerned, that when the particle re-enters region 1 through the longest possible path in region 2, the magnitude of the change in its linear momentum between the point P1 and the farthest point from the axis is this one. Whether this is correct or not, the farthest axis, the farthest point from y-axis, you can see here the magnitude of change in momentum at P1. Okay, let us take another page. For option number 3, we have this situation. At P1, this is P1, the momentum here is P is positive this side, and we have to find the momentum at the farthest point from Y. So when it re-enters in region 2, when the particle re-enters 1 through, so when it re-enters 1 through the longest possible path in the 2 is what? What is the change in momentum that will happen? So it will move something like that, and this way it will move and re-enter here. So on y-axis, from this y-axis, the farthest point is obviously this one. This is not the farthest point, so this is the farthest point. So at this point, this will be the momentum of the particle which is in this direction. In terms of magnitude, it will remain same because the magnetic field cannot change the magnitude of the velocity. It will only turn the velocity. So magnitude will remain the same. So here also it is this is the farthest point, and here also momentum is same. Here it is like this. So these two are perpendicular to each other. So final momentum minus initial momentum. This is the change in momentum. This is P, this is P. So this will be root 2P.
So root P is side mirror. Start.
So this is root 2P. So change in momentum comes out to be root 2P. But here it is given, it is P by root 2. So this option is not right. It should be root 2P. Okay. The fourth option is that, the fourth one, we will consider the fourth one also. It says that for a fixed B, if B is fixed and particles of same Q, same charge Q, charge is fixed and same velocity V is fixed, then the distance between the points P1 and the point of re-entry into the region 1 is inverse. That means if it re-enters at this point, say this is any point, say P3. So what it talks about is that when it enters at P1 and re-enters at any other point P3 is inversely proportional to the mass of the particle. That means this distance, suppose this distance is d, that says that d is inversely proportional to mass. Whether this is true or false, that will check. We know that the radius of the particle is mv upon qb. If the particle starts from here, we will consider this as the radius, and it enters again here. This is also the radius. This is the center. So that means it talks about this distance, which is nothing but twice the radius. So if you think of the radius and m relation, 2r is inversely proportional to m, whether it's true or false. You can see that if v is constant, we are making three quantities constant. We are making v constant, b constant, and q constant. Then r is proportional to m, and the 2r or d that we are considering is proportional to m. So d is proportional to m, d is not inversely proportional to m. This option is wrong. So option number 4 is also wrong. So to this question we have only two answers correct, option 1 and option 2. Okay.